The James Webb Space Telescope just showed us the earliest known objects in the universe, and they shouldn't exist at all. It also caught a supermassive black hole which formed from nothing. But how is that possible? A bizarre new object found lurking far beyond Neptune. Is this Planet 9 we were looking for? These are only a few of the latest, truly mind-bending space discoveries of 2025. And today we're going deep on them to figure out what they really mean. What if we could peek into the universe's diary and find the very first lines? That's what astronomers are doing right now with the James Webb Space Telescope. In a new article published at the end of July 2025, a team of scientists claims they have found the unthinkable. In the previous James Webb images, they've spotted what appear to be galaxies at redshifts from 17 to 25, meaning we're seeing the farthest of them as they were just 180 million years after the Big Bang. In cosmic terms, that's practically the delivery room. And here's the kicker. They're not dim, fragile smudges struggling to survive in the newborn cosmos. They're bright, almost too bright. Webb's ultra-deep surveys are revealing ultraviolet light output that smashes every prejudiced prediction, in some cases by factors of 10 or even 100. And despite their intense luminosity, the studies show these objects were astonishingly compact. In some cases, only a few hundred to 1,000 light-years across. Tiny compared to the Milky Way's 100,000 light-year span, yet already burning furiously with star formation. Think modern star clusters, but on steroids. And according to our neat little galaxy formation models, structures this luminous and this large shouldn't exist so early. They were supposed to take their time, forming slowly from small clouds of gas and dust, growing only after generations of stars enrich the cosmos with heavier elements. But instead, these galaxies are lighting up the darkness too early for it to make any sense. That mismatch has led some scientists to suggest a more exotic possibility. Maybe we're not looking at ordinary young galaxies at all. Maybe some of these points of light are powered by ancient black holes, primordial ones formed in the chaos right after the Big Bang, now feasting on gas and shining like miniature quasars. If that's true, with these tiny specks on the edge of the observable universe, we're witnessing a different kind of cosmic youth entirely, at least from what we came to expect. If this discovery is confirmed, the implications are staggering. The timeline of galaxy formation is blown wide open. The cosmic dawn might have arrived far earlier and far brighter than anyone thought possible. Either way, even with James Webb's capabilities, we've only begun to scratch the surface of what really happened in the universe's opening act. And here's the discovery that might actually explain those impossibly bright early galaxies. James Webb may have just caught a supermassive black hole form essentially from nothing. In a cosmic collision zone known as the Infinity Galaxy, two galaxies are crashing together in a beautiful sideways figure eight. And right at the intersection, floating in a glowing cloud of gas, sits a black hole 1,000,000 times the mass of our sun. At first, the astronomers thought it had been kicked out from the center of one of the galaxies, but nope. Turns out each of them still has their supermassive black hole just in the right places, which could mean only one thing. This black hole formed directly from that vast gas cloud disturbed by the galaxy collision. It's not exactly nothing, but if you suddenly appeared right there before the black hole was born, you wouldn't notice a thing around. The measurements seal the case. This black hole's motion matches the surrounding gas almost perfectly, meaning it appeared right there and didn't wander in from somewhere else. This monster didn't need a giant star with a supernova. It was just an instant collapse of gas under its own gravity. And if you can really make a supermassive black hole this way in the modern universe, then it definitely could happen in the distant past. Primordial direct collapse black holes are exactly the kind of shortcut needed to explain how these monsters appeared so quickly in the early cosmos and how they could have powered ancient quasars and probably those red shift 25 galaxies we just talked about. So this time, James Webb, in a way, gave us a proof of concept that could rewrite all of cosmology from square one, but not that it worked that much lately. Anyway, in one of my previous videos, we talked about those mysterious little red dots that appear everywhere on James Webb's deep field images. Well, surprise, surprise. Now it has revealed a new class of little red dots, not in the farthest reaches of space, but surprisingly nearby, just a few 100 million light-years away. Well, technically they're yellow because they're not that red-shifted, but otherwise they look just like the distant ancient objects in those deep field surveys. The same brightness and compact shape. It's their proximity that's the real jaw-dropper. We're possibly staring at the same phenomenon lurking close to home. So, if they are that close, then scientists must have already figured out what we're looking at, right? Well, not exactly. The leading theory on the original little red dots is a black hole wrapped in a cloak of surprisingly cool gas. A thermal envelope that shields the center and shapes its distinctive infrared signature with no X-ray emissions whatsoever. But what makes sense for the bizarre early universe doesn't seem to be applicable now. I mean, we see plenty of black holes surrounded with gas all around the cosmos, and none of them look like these yellow dots. Moreover, they're currently estimated to be as big as a solar system, and that's actually really tiny for such an object. So, what if we're looking at something completely different? What if some of these objects are supermassive stars, gargantuan stars, hundreds of thousands of times the mass of our sun, living fast and dying young, right before collapsing into supermassive black holes? Sophisticated models show that the light profiles we assign to distant red galaxies could be also produced by these stars. The only problem is, well, we have no idea how such stars could even form in the modern universe, so we could see them as yellow dots. So until more observations and studies are made, we have to settle on the fact that we currently cannot explain what these things are. Who knows? Maybe when we do, it'll turn into a discovery of a completely new kind of stellar object and a breakthrough in astrophysics. Just like the discovery of the first black holes in the 70s, speaking of giant stars, the universe has just handed us a twist worthy of a soap opera. Betelgeuse has a secret lover, partner. For years, Betelgeuse, the famous red supergiant blazing in Orion, has been the drama queen of the night sky. It swells and shrinks, brightens and dims, sometimes so unpredictably that people have wondered if it's about to go supernova. But the latest observations suggest all that erratic behavior might have a much simpler, more elegant cause. A dim partner star. A team of astronomers using high-resolution imaging compared data from the Great Dimming of 2020 with new observations taken in 2024. In the earlier images, there was no sign of a companion. Exactly what you'd expect if it were hidden behind Betelgeuse at the time. But in the most recent set, a faint point of light appeared right where the model said it should. All the evidence points to a close low-mass stellar companion orbiting inside the extended atmosphere of this swollen red giant. This changes the story entirely. That 6-year cycle in Betelgeuse's variability, the strange pulsations, the irregular dimming events. A companion star so close could be stirring up the supergiant's outer layers, shaping its clouds of gas and dust and modulating its brightness in ways that mimic internal pulsations. The interaction could even explain the massive ejections of material we've seen flying off of its surface in recent years. And if Betelgeuse isn't a solitary star, then our models for its life cycle and for massive stars in general need a serious rewrite. Binary interactions can change everything from the rate of mass loss to the timing of a supernova. They can strip a star's outer layers early, alter its spin, and completely reshape the chemistry of what eventually explodes into space. And now we have to account for that in all observations. Betelgeuse's partner might even influence how the star will die. Instead of the straightforward collapse we've long envisioned, the final act could be shaped by decades or centuries of mass exchange, orbital tightening, and gravitational tug-of-war. So, the bad news is Betelgeuse probably won't go supernova in the next few years. A bummer, I know. I've been expecting the show too. But on the other hand, it's easily a discovery of the year in stellar astronomy, if not a whole decade. Such a twist. But there are stars even stranger than Betelgeuse that are always ready to put up a show. In the southern sky, about 8,000 light-years away, lies a weird star system called AEP. Even before James Webb got involved, it was already one of the most beautiful and puzzling stellar objects known, a giant spiraling pinwheel of dust drifting through space. Now JWST has taken a closer look, and the details are even stranger than we imagined. At OPEP's heart are two massive Wolf-Rayet stars, rare dying giants that blast their outer layers into space at furious speeds. Their stellar winds collide, compressing the ejected material into a tight symmetrical spiral pattern that slowly unfurls over time. It's like a cosmic Catherine wheel frozen in mid-spark, except this one is bigger than our entire solar system. But what makes OP so weird is the physics. Wolf-Rayet winds are already some of the fastest in the universe, often topping 2,000 km per second. But in OPE, Webb has revealed something unique. The wind from one of the stars appears to be moving much faster than the others by almost a factor of 3. This mismatch produces an exquisitely regular dust spiral that shouldn't be possible if the system were behaving like any other known binary. But even with such extreme and uneven wind speeds, the spiral pattern is astonishingly consistent, winding outward in perfect, even arms over decades of expansion. The two stars are locked in a delicate dance, choreographing each step despite the violence of their own destruction. For astrophysicists, AEP is more than a pretty spectacle. Systems like this are extremely rare, and they offer a unique laboratory for studying what happens in the final stages of a massive star's life. But sometimes a single flicker can lead to a breakthrough. And exactly that happened with the unexplained X-ray source HLX-1. I know it sounds like the name of some gizmo from Star Trek or Star Wars, but actually it's an unexpected spike in X-ray light coming from the outskirts of a giant lenticular galaxy about 380 million light-years away. Not from its bright, bustling core where supermassive black holes usually rule, but from a compact star cluster way out on the galactic edge. There, astronomers spotted a source so intense it was immediately flagged as unusual. X-ray bursts often have familiar origins. A neutron star pulling matter from a neighbor or a black hole in a binary system feeding steadily from a companion. But HO1X didn't match those patterns. It was in the wrong kind of environment, far from the chaotic star-forming regions where these dramas typically unfold. And the light curve wasn't predictable. Instead of pulsing in regular cycles or glowing at a steady rate, it surged into an extraordinary peak and then slowly faded. That mystery led astronomers to a rare conclusion. HLX-1 is likely an intermediate mass black hole, the long-theorized missing link between stellar mass black holes and the supermassive giants anchoring galaxies. And it wasn't just sitting there quietly. The most likely cause of that flare was a tidal disruption event, a star venturing too close, being torn apart, and fed piece by piece into the black hole's grasp. But HL1X broke the rules. It was brighter than expected for its size, and its feeding cycle didn't match the timelines in our models. It was as if the black hole took multiple bites from the dying star over time, pausing between them, stretching the event far beyond what we've seen before. It hints that intermediate mass black holes may interact with their surroundings in ways we've barely begun to explore, and that they could be more common than we think. Hidden in dense star clusters, invisible until the day a passing star strays too close. So now we know what to look for. In a dwarf galaxy almost 400 light-years away, astronomers have just found a neutron star that makes every known pulsar look like it's running on half power. It's tiny, only about 20 kilometers across, but it's emitting the most energetic pulses ever recorded from such an object. It all started with bursts of radio waves so intense that at first they were mistaken for the kind of fast radio bursts we sometimes see from magnetars. But follow-up observations across multiple wavelengths revealed something else. These signals were repeating with clockwork precision. The unmistakable heartbeat of a pulsar, a neutron star spinning in sweeping beams of radiation through space like a cosmic lighthouse. Only this one's beam is brighter and more powerful than any we've ever seen before. And why is that? Well, because this thing is young, possibly as little as 14 years old, and no older than about 60 to 80. That means the pulsar is still spinning rapidly, and its magnetic field hasn't yet had time to weaken. It's operating at peak strength, converting its rotational energy into radiation with an efficiency that smashes through the limits our models predict. Even for the most extreme pulsars, they're supposed to have an upper bound on how much energy they can pour into their beams. But this object doesn't seem to care that its output suggests a magnetic field that's not only incredibly strong, like in a magnetar, but also unusually efficient at channeling energy into tight, coherent pulses. I mean, remember that this pulsar isn't sitting in our Milky Way. It's in another galaxy entirely. It's signal traveling hundreds of millions of light-years and still arriving bright and clear enough to grab our attention. So in the end, this single object forces us to rethink the whole life cycle of neutron stars that we thought we had nailed down a long time ago. But let's get closer to home and turn to the famous Planet 9 hypothesis that just got an unexpected update. For years, this object has been one of the most exciting ideas in planetary science. A hidden giant lurking far beyond Neptune, its gravity sculpting the orbits of icy bodies at the solar system's edge. The theory seemed elegant. A single massive world, maybe 5 to 10 times the size of Earth, quietly herding a population of distant objects into neat aligned paths. But now, a new discovery has landed that could take much of the wind out of Planet 9's sails. Astronomers have just found a small frozen world nicknamed Ammonite on the solar system's edge, like 300 kilometers across. And its orbit is exactly the kind of elongated, tilted path that Planet 9 was supposed to explain, except it's in the totally wrong place. When researchers ran the numbers, they found that Ammonite's trajectory fits perfectly into models that include only the known giant planets and the occasional influence of passing stars. No mysterious heavyweight needed. And it's the second blow to the Planet 9 hypothesis this year. Back in May, another newly discovered trans-Neptunian object, a dwarf planet, was found with an orbit that also didn't match the Planet 9-induced pattern at all. Instead of aligning with the group of distant bodies used to argue for the planet's existence, it broke ranks, undermining the supposed clustering that was one of the hypothesis's strongest pieces of evidence. Taken together, these discoveries paint a new picture of the outer solar system. Instead of being ruled from the shadows by one enormous unseen planet, it may be shaped by the combined chaotic influences of many smaller icy bodies and subtle gravitational forces working over billions of years. That's not the simple cinematic story of a hidden giant waiting to be found, but it's a richer and more complex one written in the countless frozen tracks of worlds like Ammonite. And there are probably much more waiting to be discovered. Personally, I really wanted the Planet 9 hypothesis to be true. Actually, it would be best if it turned out to be a primordial black hole formed right from the gas which then attached itself to the solar system. But no, all those super weird objects are somewhere out there billions of light years away, and all we get is another Pluto wannabe. Well, but that's science for you. Now let me know in the comments which of these recent discoveries shocked you the most. And if you enjoyed this video, like it and subscribe to the channel so I do more deep dives into the latest crazy space stuff. See you next.